Hi everyone, this video is going to be for your homework assignment called Functions Practice 2. Okay, so the first section asks us to write an equation to represent the following. So I'm going to show you how I approach these types of questions. It says take any number. When you see something like this where it says any number, you're going to use a variable, a letter. I'm just going to use x. And then it says multiply it by 3, then add 5. So there's multiply it by 3 and add 5, which looks like this. X multiplied by 3 plus 5. But first of all, it's not an equation because it doesn't have an equal sign, and this looks a little crazy. So our final answer would be y equals, we put the number before the variable, 3x plus 5. That is our equation. Okay, number 2 says take any number, so that's going to be x, divide it by 2, then subtract 1. So same thing, we're going to write this out, x divided by 2 minus 1. But we remember we need an equation, so it's going to be y equals, and this you can either leave it like this, x over 2 minus 1, or you can write it like this, x equals 1/2 x minus 1. Either one of these is fine. Okay, and finally we have take any number, multiply it by 2, then divide it by 3, then add 7. So that's x multiplied by 2 divided by 3 plus 7. Final answer, we need an equation, so that's y equals, we put our number before our variable, so that's 2/3 x plus 7. All right. Next section says state the possible domain and range values for each function below. So this looks complicated, but it's not. We know that domain is x and range is y. So a function allows only input. We also know that input is x, and this is our input, and only has output y values of these numbers. So all we have to do then, we know domain is x and range is y. So I'm going to take all of my input values and list them here with the squiggle mark around it to show that it's all part of the domain. And we usually write them in order from smallest to largest. Then our range is the output values. We do a little squiggle, -4, -1, 2, and 5. And that's it. Okay, a function produced these ordered pairs. Now we need to again find the domain, which is x, and the range. I know when I have an ordered pair, the first number is x, the second number is y. X, y, x, y. So when I write the domain, I'm going to write all of the x values. -3, 5, 12. Then for my range, I'll just switch colors here for you. I'm going to write all of my y values. 1, 13, and 19. That's it. Just reminding you that, whoops, wow, we have x is the same as the input, which is the same as the domain. Y is output and range. Okay, number 5 and number 7 asks us to state the zero. And if we remember from our lesson that the zero of a function means it is the same as the x-intercept where the y value is always 0. So if we have an equation and we're trying to find the 0, our first step is we're going to change the y to a 0, and then we're going to solve for x. So there's my x. Okay, so I need to have the x on one side and all my numbers on the other side. So if I want to cancel a plus 12, I'm going to subtract 12 from both sides. This will cancel, and I get negative 12 equals x. And that is the 0. That is the x value that will make y equal 0. Same thing here. First step, change the y to a 0. Then I solve for x. This is a two-step equation. Okay, I want to have the x by itself. I always add or subtract before I multiply or divide. So this is subtracting 15. I'm going to add 15 to both sides. 0 plus 15 is 15 equals 3x. This is multiply. The opposite of multiply is divide. So I'll divide both sides by 3, and I get 5 equals x, or x equals 5. And that is the 0. Okay, now we're going to do the same thing, but we're finding it from a graph. I know that the 0 and the x-intercept are the same. It is the point where the graph crosses the x-axis, which is right here. That is positive 3. So that's a 3 for the x and always a 0 for the y. X-intercept and 0 is the same thing, so I'm going to write it again. Another way to write the 0 is x equals 3. Then I'm going to find the, let me change the color. This is the y-axis. The y-intercept is the point where the graph crosses the y-axis. The x value is always 0, and this is 1, 2, positive 2. You always write them the same way. Sorry if you can hear my kids in the background. All right, this is repeating from the practice day 1. Determine if the following are functions and explain. Okay, this is a table, so we're going to look at the x values, 11, 15, 19, and 23. The x values are all different. They do not repeat, so I'm actually just going to write it. So that is yes, because x does not repeat. Here I'm going to highlight the x again. I have 4, 6, 8, and 4. I see that 4 is repeating, but let me check my y value. 1 and 4. They are different, so this is going to be a no, and that is because x repeats, and once again that's with different y. Okay, number 11 is a set of ordered pairs, but the same process where we're going to look at just the x values to see if they repeat. 5, 12, 14, and 4, they do not repeat, so that is yes. Whoa. Yes, this is a function, and that is because x does not repeat. Okay, and I'm going kind of quickly, but you can pause this at any point. All right, rewrite as coordinate points. That means rewrite means write again. Coordinate points look like this. So where it says rewrite as coordinate points, I can just go ahead and put my parentheses and my comma. And then we're going to state if this point could be a 0, yes or no, and why. So first we're going to rewrite as a coordinate point. The inside the parentheses is our x value. Outside the parentheses is our y. And we just write it together. -6, 0, and 0, 19. Now, I remember from the last couple questions and from our lesson that a 0 is the same as the x-intercept, and for a 0, the y value will always be 0. So if I'm looking at 12, -3, that is it's not possible. That cannot be a 0 because y is not 0. All right, the next one is -6, 0. This one is yes, because y is 0. Okay, the last one is 0, 19. This has a 0, but that's the x value. So this is no. And once again, because y is not 0. Okay, if it is a 0, the y value will be 0. All right, this one says, is what we just did before, rewrite each statement as a coordinate point. Coordinate points look like this. So I can just go ahead for each question and write it like a coordinate point. X is inside the parentheses, Y is outside. And so I'm just going to take it from this statement and write it as an ordered pair. And that is it. Okay, this one is rewrite, write again, but this time I want it in function notation. And if you remember from the lesson or you've seen in some of these questions, I'm not sure where then, you can either write an equation with a y or function notation, which is f of x. So all we're going to do to rewrite this is change our y to f of x. It means the same thing. So this is f of x equals, and then I copy the rest of the equation. This one I change the y to f of x equals 5 over 7x. This one I change to f of x equals negative x plus 4. That is the only part that you're changing. So if you ever see f of x, don't get confused. It's the same thing as y. Okay, so this one has a little more work. I did some of it ahead of time just for time. It says given the domain, so that's x. So these are all of our x values, and we see them here. We're going to find the range, then we're going to graph it, and then identify the intercepts and zeros. So when we're given an equation and we're given the x values, we are going to then know that we're going to copy our equation and put parentheses where we had the x. Then we're going to replace the x with each one of these domain values and find the answer. So I put this right into Desmos, I copied it perfectly, and then inside the parentheses I put my first x value, and then my answer, whoops, was positive 2. Next, I put in negative 3, and I got 0. Whoa. Next 3, we get negative 4, and you do want to practice putting this into Desmos yourself, and you can just actually type it one time and then keep deleting what's inside the parentheses. And then our last one is negative 6. Okay, so now we're going to go ahead and put these points on the graph. Each pair is the same as an ordered pair. So the first point I'm going to put on is negative 6, positive 2. So 1, 2, 3, 4, 5, 6, 1, 2. That's my first point, and I'll just change the color. So I'll do blue for the next one. Negative 3, 0, 1, 2, 3, and 0. 3, negative 4, 1, 2, 3, 1, 2, 3, 4. And finally, that's 6, negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so there is my graph, and I actually I see my x-intercept right here, but I don't see my y-intercept. So I'm going to use the slope to help me find my missing point. So I see that this is down 2 and over 3. So I'm going to go down 2 over 3, and there is my y-intercept right there on the y-axis. So let's make this x and y and 0. This is our x-intercept on the x-axis. We write that as negative 3, 0, always. This is our y-intercept on the y-axis, and that is 0 for the x and negative 2 for the y. If you weren't sure where to put that point, you could also keep doing this and substitute in a 0 for the x to see what happens. Okay, then we know the x-intercept and the 0 are the same. So I'm going to copy it again, or you can write it like this. Okay, you can skip number 20, and I'm actually not sure if you have this on your, I think we did this in the notes instead, so I'm going to go ahead and stop the video here.